In this video, we're going to multiply and divide complex numbers, but we're going to transition into doing it using the complex form. So we're going to use two numbers that we already found the complex form of the numbers in a previous video, but we're going to go back to the original way, the traditional way that we have multiplied complex numbers first. So to multiply this complex number, you would FOIL it out, distribute each real and an imaginary part to the other. So 2 times minus 4 is minus 8. And 2 times 5i is plus 10i. 3i times minus 4 is minus 12i. 3i times 5i is plus 15i squared. And then we immediately say that I squared is negative 1, so this becomes negative 15 altogether. And we combine our like terms, so we have negative 8 minus 2i minus 15. And so the product of those two complex numbers is negative 8 minus 15 is negative 23 minus 2i. So if I was to sketch this on my complex plane, we're going over negative 23 and then down 2. So here my complex number would be over here, negative 23 minus 2i. And I point that out because I want to think about what would this absolute value be and what would this argument be, right? So let's do this multiplication using the complex form. And if we remember from our notes from the last lesson, we had 2 plus 3i was the same as the square root of 13 times the cosine of 56.3 degrees plus I sine of 56.3 degrees. And then we're going to multiply that by the square root of 41 times the cosine of 128.7 degrees plus I sine 128.7 degrees. Now when you multiply in the complex form, all you do is you multiply the absolute values. So we would say the square root of 13 times 41. And then you add the arguments. And so we would say cosine of 56.3 degrees plus 128.7 degrees plus I sine 56.3 degrees plus 128.7 degrees. So for more and more complicated problems, this algebra step is easier than the foiling and resolving that square root of that I squared into negative 1. And so let's just add 56.3 times plus 128.7, and we get 185 degrees. And 13 times 41, so this becomes the square root of 533, and we have cosine of 185 degrees plus I sine 185 degrees. Now let's just confirm that this is equal to that. Is this product the same as this product? Because they have to be, because I multiplied the same two numbers. This was what we called Z1, and I multiplied it by Z2. And down here, this was Z1, and this was Z2. So it should come out the same. So let's distribute our root 533 back in. So the square root of 533 times the cosine of 185 degrees, and we get negative 22.99, so this becomes negative 23. And then if we do the square root of 533 times the sine of 185, we get negative 2, so plus negative 2i, which is the same answer. So it doesn't matter whether you do the traditional rectangular form or the polar form, you're going to get the same answer. And now let's just take a look at this, right? Let's look at what is the square root of 533, right? Well, it's 23.086, so the magnitude of this absolute value would be 23.1, and the argument 185 degrees, right? This argument makes sense because look at, that's about 185 degrees. So this complex form and this complex form are the same when you do this product. Now let's look at division with complex numbers. And division with complex numbers is a little bit longer of a process in the rectangular form because we learned in the last video that we have to multiply by the complex conjugate to do division. So let's do -4 plus 5i divided by 2 plus 3i. And if I do this in the rectangular form, the division is really a multiplication of the complex numbers of the complex conjugate. And so I multiply the top by the complex conjugate, the numerator by the complex conjugate, and I get -8 plus 12i plus 10i minus 15i squared. And then on the denominator of this, we get 4 plus 6i minus 6i minus 9i squared. And when we simplify that, remember this becomes a plus 15, so -8 plus 15 is 7, and 12 plus 10 is plus 22i. In the denominator, I get 4, these cancel, and then the I squared turns out to a plus 9 over 13, so 4 plus 9 is 13. And so my complex number is 7 over 13 plus 22 over 13i. So let's just think about where this would be in our complex plane, a little crooked complex plane here. Okay, so if I made this 1, 2, 1, 2, 7 over 13 would be about here, and 22 over 13 would be a little less than 2, so we're somewhere around there, 7 over 13 plus 22 over 13i. That would be if I divided, so -4 plus 5i divided by 2 plus 3i. That was the problem we started with. And then we said, okay, in order to do that division, you take your number and you multiply it by the complex conjugate over itself, because remember, this fraction is just 1. So I'm just changing the form of this so that I get a traditional form of the complex number, a rectangular form. So now we're going to take these numbers, and we know these in their trig form. So in their trig form, we had the square root of 41 times the cosine of 128.7 degrees plus I times the sine of 128.7 degrees. And we're going to divide that by the square root of 13 times the cosine of 56.3 degrees plus I sine of 56.3 degrees. Now remember, this numerator, that's one number. That is -4 plus 5i. The denominator, that's one number. That's 2 plus 3i in the complex number system. So when you do division, you divide the absolute values. So we would have the square root of 41 over 13, and then you subtract the angles, 128.7 degrees minus 56.3 degrees, plus I sine 128.7 degrees minus 56.3 degrees. Okay, and when we do that subtraction, we get 128.7 minus 56.3, 72.4. And so we have the square root of 41 over 13 times the cosine of 72.4 degrees plus I sine 72.4 degrees. Now we could rationalize the denominator. I'm not going to do that here. So this was z2 over z1, because remember we had z2 was our -4 plus 5i, and z1 from our earlier problems was 2 plus 3i. Now let's confirm that this makes sense. So let's see, what is the square root of 41 divided by 13? So the square root of 41 divided by 13 is 1.7759, approximately. Okay, cosine of 72.4 degrees plus I sine 72.4 degrees. Let's just look at our diagram before we multiply this in. Does it make sense that the absolute value of that point might be around 1.8? Sure, that makes sense. This is 1, this is 2. That makes sense, right? That's a reasonable number. Does it make sense that the argument might be 72 degrees, around 72? Sure, that confirms this diagram, right? So now let's take a look, and we'll just distribute this 1.7759 in. So we'll multiply that number by the cosine of 72.4, and we get 0.302. So this is 0.302 plus, we'll multiply the square root of 41 divided by 13. And we'll multiply that by the sine of 72.4. And we get plus 1.69 times I. So Z2 over Z1 is equal to that. Now let's see if our numbers up here. 7 over 13, 7 divided by 13 is equal to, oh shoot, I didn't multiply the 1.7759 by the cosine. This number is wrong. Sorry. The other one is fine, but 0.304 is the cosine of 72.4. It's not the product of the 41 over 13. So I'm going to do that again. 41 divided by 13, square root of 41 divided by 13, and then I'm going to multiply that by the cosine of 72.4. That other number I had put here, that was just cosine, not the product. So 0.537. Okay, and now let's look. 7 divided by 13 is 0.538. So because of the rounding of our angles and the rounding of our radical, we are off by 1,000th. Okay, because this is I'll write this up here. Right? 7 divided by 13 is 0.538. Oop, there's not going to be room there, so I think I'll write it to the left of it. Right, so this is going to be 0.538 plus, let's do 22 divided by 13, and we get 1.69, the same that we got with our trig answer, so 1.69i. So this is the rectangular, and this is the trig. But when you start doing many of these problems, if you look at the number of steps it was to do it in the rectangular form, first you had to multiply by the complex conjugate, then you had to FOIL out both the numerator and the denominator, then simplify, then separate. And down here, all you had to do is divide your absolute values and subtract your angles. So divide the absolute values, subtract the angles, and this was the answer. The other two steps were just to confirm, these two steps were just to confirm that they matched. Okay, so the answer is this here. And so let me just give you the general formula when you're multiplying and dividing complex numbers. So if you have Z1 times cosine of theta 1 plus I times sine of theta 1, and you have Z2 times cosine of theta 2 plus I times sine of theta 2. And these represent two different complex numbers. Right? So we're just talking about two different complex numbers. If I want to multiply, in fact, let me just rewrite this. Let's call this Z1 is equal to the absolute value of Z1 times the cosine. Z2 is equal to the absolute value of Z2 times the cosine. Okay, so if I want to multiply Z1 times Z2, it's going to equal multiply the absolute values, so that's the number, the product of the two absolute values, and then add the angles. If I want to divide Z1 divided by Z2, I'm going to divide the absolute values, and I'm going to subtract the angles. In the long run, this is a much easier way to multiply and divide complex numbers. Okay, and then there's some practice problems that you can try.